dot product, then a very late dinner. Okay, so the dot product of two vectors, couple of things. Number one, there's two formulas for it. And before I forget to mention, the dot product can happen in 2 space and it can happen in 3 space. So just a reminder, because there is a calculation coming up later in this unit which only is available to be done in 3 space, so 2 space won't count. This one is both of them. So one of the formulas is this thing right here. So lots of little notation bits to it. So for two vectors, vector A and vector B, with a common tail, so here's a vector A and here's a vector B, and there's the common tail, and some angle theta between them, the dot product calculation, the formula, is the magnitude of A multiplied by the magnitude of B multiplied by the cos of whatever angle that is. And you can do that in either radians or degrees. Now, because this is a number value, magnitude or length, and this is a number value, magnitude or length, and this is a number value, that means you've got a scalar times a scalar times a scalar, so the dot product of two vectors actually is a scalar answer. So sometimes you will see the dot product also referred to as scalar product, but dot product is pretty popular. So here is an example. Oh my gosh, it's radians. I'm going to move number 2 out of the way so I have a little bit of space, and then I'll come back and read A. So I don't have this formula memorized yet. It'll probably lodge into my brain as I go through this unit. But given that the magnitude of A is equal to 16, so the length of vector A is 16 units, and the length of vector B is 7 units, and the angle between them is pi over 6, that means I'm being asked to find the dot product of A dot B. So you actually say that A dot B. Vector A dot vector B. Okay, so I'm going to recopy this formula. Fortunately, I'm still using A's and B's. So the dot product of vector A and B is equal to the magnitude of vector A multiplied by the magnitude of vector B multiplied by the cos of theta. So there's the formula. The magnitude of vector A is 16. The magnitude of vector B is 7. And theta, the angle between them, is pi over 6. Now you may remember, or may not remember, from advanced functions that this is radians, and to convert to radians, you multiply by 180 over pi, so that the pi's cancel out, and you just have 1 times 180 divided by 6 times 1, so that is 30 degrees. So if you're more likely to get things right because your comfort level is with degrees, feel free to change it, but make sure you know how to change it. So we need to find out what the cos of 30 degrees is, and I hate to say this, I'm grimacing. This is a unit circle measurement. So it's this area of the unit circle, and it's 0 over 2, 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2 is 1, and then backwards up here. And I taught you that, and if you can't remember it, it's in the history lesson part of, I think it's the second trig unit in the advanced functions notes. So this is the 30-degree mark, or if you prefer, pi over 6, and cos is the first coordinate, because it's alphabetical, which means I can replace cos pi over 6 with root 3 over 2. And I'm going to keep 16 as 16 and 7 as 7. over 1 over 1. If you prefer, 16 divided by 2 is 8 times 7 is 56 root 3, and that is the dot product, which at this point for you is a calculation that is meaningless. Okay, so the next questions. So don't be upset by the meaningless of this. We'll get to it. And let me just check. I don't trust me for 2 reasons. First of all, I'm going to find the cos of 30 degrees and just check to see if I really believe it's root 3 over 2, and it is. And 16 times 7 times root 3, which I'm not going to put into my calculator, divided by 2 is 56 root 3. So I feel better about myself now. Now I've got this little note to myself that says, add in from next slide. So the next slide has some information on it that will help with this question. So 2 non-zero vectors, so that means we've actually got 2 vectors, A and B, that are not 0, and they're perpendicular, and we want to determine the dot product of vector A and vector B. Now what that means is that I'm going to dig out the formula, even though I don't have all the information. So A dot B is the magnitude of A times the magnitude of B times cos of the angle between them. And if these 2 vectors are perpendicular, that's saying they're 90 degrees. So I'm at least going to put that in. I have no idea how long A is, so I don't know the magnitude of A, and I don't know the magnitude of B. But I do know, based on my unit circle, that the cos of 90 degrees is 0. So to be perfectly honest, it doesn't really matter what the magnitude of A is and what the magnitude of B is, because I'm just taking it and I'm multiplying it by 0. And that means my answer is 0. So that also means, for part B, that if 2 non-zero vectors A and B have a dot product of 0, so I don't know what the vectors are, but their dot product is 0, it says determine the angle between A and B. And for this to be a 0, this angle has to be 90 degrees, or if you prefer radians, pi over 2 radians. That's the only way you're going to be able to create a 0, because this is non-zero and this is non-zero. So there must be some component of this that is 0, and that must be cos 90. So I can say, without a doubt, therefore, the angle is 90 degrees, and I'm going to say or pi over 2 radians just to show off. So then we come to what's on the next slide. So this is a bunch of facts. 2 perpendicular vectors have a dot product of 0. Let me say that again, and then I'm going to go back to the last slide. 2 perpendicular vectors have a dot product of 0. I had 2 perpendicular vectors, and the dot product ended up 0. Next statement, 2 non-zero vectors with a dot product of 0 are perpendicular. Let me read that again and then go back to the last slide. 2 non-zero vectors that have a dot product of 0 have to be perpendicular. Because if this isn't 0 and this isn't 0, this part must be 0. And if that part is 0, the only number that can be placed in there is 90 degrees. technically it could be 270 degrees as well, because if this is 90 degrees, that's 270 degrees. But normally we don't talk about the wider angle, we talk about the narrower angle, not acute, narrower angle, because it's 90. So, new terminology for you. Two non-zero vectors, vector A and vector B, are perpendicular if and only if A dot B is equal to 0. So when you see if and only if, that is saying that it doesn't matter which way you read the statement, it is still true in both directions. So this says that two non-zero vectors, A and B, are perpendicular and the dot product is 0. It's also saying if the dot product is 0, you know they're perpendicular. And the symbol for this in mathematics, and I say symbol, it's not even an acronym, it's just a short form, is anytime you want to say if and only if, it's IFF. So it's if with an extra F. Another thing I want to tell you, in case we haven't looked at it yet, maybe in advanced functions, is perpendicular and orthogonal mean exactly the same thing. So if you see the word perpendicular, it means 90 degrees. If you see the word orthogonal, that means 90 degrees as well. So new word to your vocabulary. All right. Second formula. It's actually a two-part formula because, like I said in the first slide, the dot product applies for R2 and R3. But like the previous notes, R3 is just an extension of R2. So this question says, in R2, if you've got vectors A, which is made up of components, see square brackets, x1, y1, and B, which is x2, y2, to find the dot product, the second formula, it is to take the x components, multiply them, take the y components, multiply them, and add together in between. That is your second formula. And your second and a half formula is three space, where if you've got a vector A that is x1, y1, z1 as its components, and vector B is x2, y2, z2 as its components, when I ask you for A dot B, that'll be the x's multiplied together plus the y's multiplied together, so same as above, then the extension plus the z's multiplied together. So like I said, you have two separate formulas and you have to be able to use them both. So you use these formulas when you're given components, and you use this formula when you're given magnitudes and angles. So it depends on what the question is giving you as to which formula you use. So when we did this question, we were given an angle and some magnitudes. Even in this question, we were given an angle. It was a bit hidden. The magnitudes didn't end up mattering. When I get to my example here, it says given vector A that has components 5, negative 3, 7, and B, which has components -2, -4, 3, I want to know what A dot B is. So vector A dotted with vector B. So there's no way to use this formula. There is a way to use part of it. I mean, you could struggle through and find the magnitude of this vector because you have a formula for it. It's x squared plus y squared plus z squared square rooted. And you could do the same for this, but you have no idea what the theta is. So you can't use that previous formula. You have to use this one. And you have to use the three-space version because I gave you three-space vectors. So here is my calculation. Vector A dot vector B equals 5 times -2, which yes, you can do in your head, plus -3 times -4, which yes, you can do in your head, plus 7 times 3. So x's multiplied together, y's multiplied together, z's multiplied together. Remember, they're called components. So this is negative 10 plus 12 plus 21. So if I'm not mistaken, 2, that should be 23. And again, a calculation that is fairly meaningless. So this is a knowledge-based question. Can you use the formula appropriately? Can you figure out which formula to use appropriately? All right, so you don't just do the dot product because you are really good at calculations. You actually use it for a purpose, like all the other calculations we do. So here are some more questions. 2 more, in fact. So I do not know how much space this is going to take. I may have to move that even further. So it says determine the angle between vectors u, 3, 4, negative 1, and vector v, negative 2, 1, and 3. So, because I've got components, I know that I can do what I just finished doing. So 3 times negative 2 plus 4 times 1 plus negative 1 times 3, and I can find the dot product. Yay me, I found the dot product. That's not what's being asked. It's being asked for the angle. So I've used one version of the dot product formula. I've got another one. I've got the original, the one that brings in angles. So that might let me find the angle, because now I know that I can put a negative 5 over on the left-hand side. But I don't know the magnitude of u, and I don't know the magnitude of v. So I can figure them out. So the magnitude of u is 3 squared plus 4 squared plus negative 1 squared, all under a square root sign. So 9 plus 16 plus 1 is root 26. And then I can do the same thing for vector v. So negative 2 squared plus 1 squared plus 3 squared. I do need a teeny bit more room. Under a square root sign. So that's 4 plus 1 plus 9, which is 14 under a square root sign. So I filled in all the pieces to this puzzle except the theta, which is a really good thing because that's what it's asking me for. It says determine the angle between the vectors. So here is something that's going to be a challenge for some of you. This reaches back into grade 11 math. It also reaches back into advanced functions. So I am going to try to get cos all by itself, cos theta all by itself, which means I need to take negative 5 and I need to divide it by root 26 and root 14. Now, just because I've got a calculator here, I can take 26 and I can times it by 14, and I can write negative 5 over root 364 if I prefer. It's totally up to you which version you like. Now, we haven't hit the grade 11 / advanced functions marks yet, or work yet. Oh, I need more space. Just to be safe. So here's the thing that happens right now. We are trying to solve a trig equation, and with trig equations that the numbers do not appear on the unit circle, that means we have to dig out the good old cast rule. This meaning all ratios are positive, so no. This meaning sine ratio is positive, Maybe. This meaning the tan ratio is positive. Maybe. This meaning the cos ratio is positive. Definitely not. So I'm not allowed to be in this quadrant because all things are positive here, all ratios. Not allowed to be in this quadrant, so I'm in this one and I'm in this one. And then a reminder to find your RAA, the number that I'm going to put between the stick and the x-axis. You have to take out the negative from the calculation. The negative helped you place what quadrants you were in. So now it's time for the calculator. So this question couldn't be a question that gets asked at a school that doesn't let you use a calculator unless this number here turned out to be a unit circle measurement. So 5 divided by 364 square rooted equals, so that's the decimal. And then I have to do second function, I have to do second function cos, and I get 74.8 degrees. And that is this space and this space. So this rotation is 180 minus 78.4, and this rotation is 180, so this is 180, plus 78.4. So I'm going to do my therefore statement and my calculations at the same time to answer the question, which is to determine the angle between the vectors. So therefore, the angle is 105.2 degrees, or 258.4 degrees. And yeah, there could be two answers. So if I made a fake 105.2 degree angle, this is 258.4 degrees. So it is the same answer. It depends on if you want the reflex answer or if you want the non-reflex answer. All right, next sort of semi-application question. For what value of k are the vectors m, which is components 2, -9, 5, and t, components 7, unknown k, and -13, what value of k makes these orthogonal? So orthogonal means that the dot product is 0. Orthogonal meaning 90 degrees, meaning perpendicular. Now I don't have vectors a and b, I have vectors m and t. So I'm going to do my calculation. So the dot product of m and t is equal to 2 times 7 plus -9 times k plus 5 times -13. So that is 14 minus 9k minus 65. So that's -9k subtract 51. So that's the dot product. And because it's orthogonal, I can put a 0 here, and I can solve for k, which, because you are in a 4U class, it means that it doesn't have to be tidy. It can be a decimal or a fraction. So I can divide 51 by 3 17, so negative 17 and 9 by 3, and that is my awful looking k value. That is the only k value that's going to make these two vectors 90 degrees to each other. All right, so that's the stuff. Again, with the R2 and R3 split, so that you're working with both sets of formulas. And that is all for dot product for now.